going to take this problem all the way to completion, but I'll give you a very good head start. Here's the original problem, and the directions are to find the indefinite integral using the substitution x equals 2 secant theta. So this is a trigonometric substitution. And basically what we're trying to do is get rid of this radical. There's other ways to find the antiderivative of this, but this is by trigonometric substitution. So if x equals this, dx equals 2 secant theta tangent theta d theta. And by the way, down here I've drawn a little triangle that makes use of the fact that if x equals 2 secant theta, that secant theta equals x over 2. So you can kind of picture, here's the angle theta. The secant is x over 2. So the opposite side theta must be the square root of x squared minus 4 by the Pythagorean theorem. And that tells us that the tangent of theta is going to be this expression right here, the square root of x squared minus 4 over 2. We'll use that later. Okay, so now we're ready to try some substitutions. X cubed would be 2 secant theta, the quantity cubed. Under the radical, we have x squared, which would be 4 secant squared theta, and then we still have this minus 4. And then dx is 2 secant theta tangent theta, d theta. So the whole key is that this radical right here, if you factor out a 4 from both terms, you get 4 times the quantity secant squared minus 1. But secant squared theta minus 1 is the same as tangent squared. And now you can take the square root of 4 tangent squared theta and get 2 tangent theta. That's where this came from right here by simplifying this radical. Now if we collect all the numerical coefficients, we get a 32 out front. We've got a secant to the 4th power because there's a secant cubed and a secant. And we've got a tangent squared, tangent times tangent. Okay, so there's what we want to find the antiderivative of. And there's probably formulas in your calculus textbook that show you how to get the antiderivative of something like this. The idea is, since these powers are both even, we strip a secant squared and let u equals tangent of theta. Du equals secant squared theta. That's why we stripped a secant squared, because this guy right here, there's the strip, that becomes du, and secant, the remaining secant squared, since I stripped 2 of these, is 1 plus tangent squared theta. And now I can do the u substitution. Tangent squared is u squared, tangent squared is u squared, secant squared theta d theta is du. Distribute this u squared, and we get u squared plus u to the 4th. Find the antiderivative of each of these terms, 1/3 u to the 3rd plus 1/5 u to the 5th. And now here's where it gets a little bit tricky. U is the tangent of theta, but the tangent of theta is this expression right here. So we have to write 32 times the quantity, 1/3. U is the tangent of theta, but the tangent of theta is the square root of x squared minus 4 over 2. And that quantity is raised to the 3rd power. I should have parentheses there. And plus we do the same thing over here. Then there's various ways to write that antiderivative. But don't forget your plus c at the end. Okay, hope that helped. If you have any questions, post a comment.